Hey everyone, welcome to The Explainer. Today we're diving headfirst into what is, honestly, one of the most consequential decisions a platform engineering team is ever going to face. We are talking about the ultimate build versus buy dilemma in container orchestration. It's the heavyweight matchup, vanilla Kubernetes going head-to-head with Red Hat OpenShift. Let's get right into it.
So I want you to ask yourself a super simple question, but one that really gets right to the heart of everything we're talking about today. Is your platform actually helping you move faster, or is it slowing you down? It's that simple, right? Your choice of container orchestrator literally dictates the amount of daily friction your team deals with, their deployment velocity, and at the end of the day, your organization's entire infrastructure bill.
To unpack all of this, here's our roadmap for the explainer. 1. The orchestration dilemma. 2. Architecture and management. 3. Navigating DevOps and CI/CD. 4. Securing the cluster. And 5. Making the final choice.
Section 1. The orchestration dilemma. Build flexibility versus buy simplicity.
Okay, to really grasp the technical side of things, we've got to talk about the core philosophies here. It really boils down to flexibility versus simplicity. Let's start with standard vanilla Kubernetes, which is maintained by the CNCF, the Cloud Native Computing Foundation. The best way to think about Kubernetes, it's like the raw, incredibly powerful engine of a high-performance sports car. It's this highly modular, extensible framework giving you all the core primitives: pods, services, deployments, the whole shebang. And hey, it has zero licensing costs and gives you absolutely maximum architectural flexibility. But yeah, there's a major catch. You have to build the rest of the car yourself. You're the one on the hook for assembling the networking, setting up monitoring, and wiring all the security layers. It's all on you.
Now, let's contrast that with Red Hat OpenShift. If Kubernetes is just the engine, OpenShift is the fully loaded vehicle straight off the dealership lot. It's a fully integrated, proprietary enterprise platform as a service. What they've done is layer security guardrails, developer tooling, and this really unified web console right on top of that core Kubernetes API. So you get an enterprise warranty, 24/7 support with strict SLAs, but in exchange, you're trading away a chunk of that underlying limitless customization.
Section 2. Architecture and Management, Foundations and Edge Connectivity.
So let's see how those two very different philosophies actually manifest physically in the cluster architecture, starting right at the operating system level, because the infrastructure behaves totally differently in these two environments. Vanilla Kubernetes gives you total OS freedom. Want to run Ubuntu? Go for it. Rocky Linux? No problem. And because of that freedom, you can do these really fast concurrent upgrades across your worker nodes. OpenShift, though, it takes a much tighter, controlled approach. It strictly requires Red Hat CoreOS, which is an immutable, container-optimized operating system. It basically treats your host nodes like ephemeral appliances to completely prevent configuration drift. Because of that, OpenShift forces you into sequential, synchronized upgrades. Honestly, it's a bit slower, but it absolutely guarantees that your OS, your container runtime, and your control plane are perfectly flawlessly aligned.
And you know, a really perfect example of this difference is how they handle the edge. Just getting traffic into a standard Kubernetes cluster requires the Ingress API, meaning you have to manually install and manage an external controller, something like Nginx. But OpenShift provides routes natively, right out of the box. It's powered by a built-in HAP proxy router. This is huge because it supports advanced TLS termination models from day one. Whether you want edge decryption right at the router, pass through straight to the pod for end-to-end encryption, or re-encryption for maximum defense and depth, it's just there, ready to go.
Section 3. Navigating DevOps and CI/CD workflows and GitOps integrations.
Okay, architecture is great and all, but let's talk about how developers actually get their code running inside these clusters, because this is where the daily dev experience really splits. In a standard Kubernetes setup, your CI pipeline is typically relying on declarative Docker files, and you've got to bring your own external tools like Kaneko or Builda to execute those builds inside the cluster. OpenShift completely changes the game here with a native framework called Source-to-Image, or S2I. S2I is amazing. It automatically generates reproducible container images directly from your application source code. It essentially injects your code into a pre-built builder image, which totally saves you from the massive headache of manually writing and maintaining endless Docker files.
And OpenShift actually takes this a step further by weaving it right into a native GitOps workflow. So instead of stitching a bunch of disjointed tools together, OpenShift pipelines and OpenShift GitOps are fully integrated via the operator hub. The flow is incredibly smooth. A code push triggers a pipeline natively run by Tekton. Tekton builds the image, then Argo CD, which is acting as an in-cluster controller, automatically synchronizes that desired state directly from Git to the live cluster. And boom, your application deploys. It's a completely seamless, pre-integrated loop.
But hey, if you're a builder on vanilla Kubernetes, you have the absolute freedom to assemble a bespoke, best-in-class toolchain. Need native multi-tenancy? Grab Octopus. Want AI-driven deployment analytics and cost control? Plug in Harness. You can use Spinnaker for these massive multi-cloud rollouts, or BuildKite for highly scalable cluster-based agent management. Heck, you could even wire up GitLab CI/CD with secure cluster agents. The burden of making all these tools talk to each other? Yeah, that's entirely on you. But the customizable power you get in return is literally virtually limitless.
Section 4. Securing the cluster, from shift left to runtime.
Let's be real. Securing a highly distributed microservices environment is notoriously complex. In the DIY Kubernetes world, security demands a super robust shift-left strategy where you have to build the toolchain. Amidst all the YAML wrangling, you're going to find yourself juggling a ton of tools. Things like kublinter to catch manifest and Helm chart misconfigurations early on. Checkov to ensure your infrastructure as code complies with CIS or NIST standards. Trivy for finding vulnerabilities and generating SBOMs. You might even want to layer in Kubescape for end-to-end risk scoring, or use cosign and sigstore to cryptographically sign your container images. It's incredibly powerful stuff, but wow, it is a lot of moving parts to manage.
And of course, security doesn't magically stop once you deploy. For runtime protection and policy enforcement, you're the one actively building that defense perimeter. You're setting up declarative policy enforcement with Kyverno or OPA Gatekeeper. You're trying to get deep cloud-native threat detection and visibility with Falco using eBPF. You're locking down kernel-level networking and security with Cilium or Calico, and maybe running KubeBench for CIS benchmark auditing. It is a fantastic, rock-solid defense-in-depth approach. But again, you are the architect. You build it, you maintain it.
Now, contrast that entirely DIY security toolchain with OpenShift's highly opinionated, out-of-the-box setup. OpenShift fundamentally restricts what can even run in the first place. By default, it enforces strict security context constraints, or SCCs. It absolutely prevents containers from running as root unless you explicitly bypass it. Now, fair warning, this will break a lot of generic Docker Hub images right out of the gate, but it guarantees a rock-solid baseline enterprise security standard. Oh, and it also natively integrates identity management directly into the platform's RBAC system, so that's one less thing you have to wire up yourself.
Section 5. Making the final choice. Evaluating the trade-offs.
Okay, we've covered the philosophies, the architecture, the workflows, and the security, so what does this all mean? Let's weigh the true cost of ownership side by side. Vanilla Kubernetes? Free. $0 license cost. It gives you maximum flexibility and insane industry adoption. But the limitation? It requires a massive platform engineering lift to actually make it production ready. Remember, free puppies still need vet care, right? OpenShift, on the other hand, is going to run you about $12,000 or more for an annual subscription. For that price tag, you get pre-integrated tools, simplicity, and SLA-backed support. Your target audience here is definitely enterprises prioritizing simplicity, but you do have to accept that higher upfront cost and some degree of vendor lock-in risk.
Which brings us to this fantastic quote from our source materials that just hits the nail on the head. It perfectly summarizes the core strategic takeaway of this whole explainer. OpenShift wins for regulated, risk-averse organizations. Kubernetes wins when flexibility, cost control, and platform ownership matter more. It's really that simple. If your main goal is building a bespoke system that's tuned to your team's exact operational quirks, and you have the deep DevOps expertise to do it, Kubernetes is absolutely your playground. But if you need compliance, bulletproof support, and rapid speed to market without babysitting all the underlying plumbing, OpenShift is the clear winner.
Ultimately, I want to leave you with a final thought to reflect on regarding your own team's bandwidth and your long-term goals. Do you want your team to be platform builders, dedicating their valuable time to architecting and maintaining infrastructure? Or do you want them to be platform consumers, focusing entirely on shipping actual application features to your users? Your answer to that question? That's going to tell you exactly which path to take. Thanks so much for joining me on this explainer, and keep building.